Geometry lesson on slopes. We'll be dealing with parallel and perpendicular lines. Uh, so the first part, lesson one, will be on parallel lines, and section two will be on perpendicular. But I think the entire lesson boils down to the fact that we know that the lines are parallel if the two slopes are equal to each other, and we know they're perpendicular if I think we say that if the slope is negative reciprocal of each other, right? More algebraic way of saying that is the product of the slope is -1. So if you think about it, right? If the first slope is, let's say, a over b, the negative reciprocal, let's say second slope is b over a. So that's the way you guys memorize it, right? But if you actually multiply it together, a over b times negative b over a, that's negative a over b is -1, right? So I believe this is a more succinct way of stating it. So going forward, that's the way we're going to show that two lines are perpendicular to each other. But we'll continue on first initially with studying parallel lines. So the theorem says two non-vertical lines are parallel if and only if they have the same slope. The reason why we say that it is a vertical line over here, guys, is that the vertical lines are undefined, right? Right. Because it's undefined, you can't really compare it to the next number. But if the two, I think the implication is that two vertical lines are parallel to each other. Okay, so it doesn't say it, but the two vertical lines, because they are both undefined, are parallel to each other. Okay, vertical lines. Okay, here you go, guys. We're supposed to show that given the quadrilateral, we're supposed to show that ABCD is a trapezoid. The key thing about trapezoid versus parallelogram is that only one pair, right? Only one pair of opposite sides are parallel. Now, we know that you could tell from the graph that these two are not parallel, right? But this two appears to be parallel, AB and DC. Now, we're going to, unlike before, like I had told you guys, to make our loss a little easier, you could just draw a picture over here to find out what the slope is. But I actually want you to, starting now, tell me what the points are. So for example, A is 0, 1, B is 3, 2, and C is 3, -1, and D is -3 and -3. And I just want you to show me the calculations. So for example, what is the slope of AB? That's change in y and change in x, right? So looking at these two values, the two y values, and we decide that I'm going to go right minus the left, right? So that's 2 minus 1. And change in x, the right minus left gives you 3 minus 0. And that my answer is 2/3, right? Oopsie, that's actually, sorry, 1. You could still do this. I mean, you could still count 1, 2, 3, 1. Yep, that's 1/3. So visually check. Doing the same thing with DC, I think we end up with -3 minus -1, -3 minus 3. Remember, right minus the left, that's this one. Right minus the left, this one. And that yields -2 over -6, which is 1/3. So we know that because since slope of AB is equal to the slope of DC, we could then say that the AB is parallel to CD. But we're not done, because what if these two sides are parallel? I know that we can't see, right? So this is what we do. I think it's still okay to recognize that this is vertical, right? So you could say that the slope of BC is vertical, therefore it's undefined, right? We could say it's a vertical line. Either one is okay with me. And then how do I find the slope AD, right? So if I compare D and the A, right minus left, right minus the left, you could do it that way, right? But before you go continue further, when you do it this way, I know slope is positive from left to right, right? So I expect a positive value, around 1-ish, right? Okay, guys. Once again, AD, so you go A and a D. I'm going to go right minus the left, right minus the left. When you do that, it is -3 minus 1. Oopsie, yeah, it is. Over -3 minus 0. That will give you -4 over -3, which is 4/3. So we could clearly see that the slope of BC is not equal to slope of AD, right? All right, we did two things. We show that one opposite pair is parallel, the other is not. Therefore, we could say the quadrilateral ABCD is a trapezoid. Okay, guys? All right. Okay. And then the next set of questions, 10.1.4, that's actually from your textbook, number 4, right? How do I do this? Okay, first of all, I think we should draw this in, right? So what is A? A is 3, -3, which is here. Yeah. My B is -1, -2, right there. That's my B. Let me just draw that in so that, there you go. And then we have D is, well, what's a D? 5, -1, which is here. Okay. So I draw a line over there. Okay. Now the question is, we're going to find C, right? And it said using slope. Ooh. Okay. I don't think we need to do anything like really complicated, but we could kind of see that the slope over here is this 1 going down, and that right there is what? 1, 2, 3, 4, right? So we could do the same thing. 1, 2, 3, 4, 1. I think that's my C right there, right? I just need to check though. Use slopes to check your work. So I'm claiming that my C has to be 1, 0, right? So how do I check? Well, we know that the both pairs of the opposite sides are parallel. Okay, so what is the slope of CD? Okay, I'm going to add C is equal to 0, 1. That is right minus the left, right minus the left, right minus the left. Yeah? All right. That'll give you 0 minus minus 1 over 1 minus 5. Changing y and changing x. That didn't look right. Okay. All right, let's check it out again. Yeah, that was not correct. So that's 1 minus minus 1, and that is 0 minus 5, right? So that would give me 2 over -5. So that is 1, 2, 3, 4, 1. No, that is not right. That is wrong because I didn't write it correctly. That's 1, 0, right? Silly me, silly me. So just be careful, guys. Because how did I discover that mistake? By looking back at the graph and saying that, hey, my slope should be -1/4, right? All right. Writing mistakes do happen, so just be careful. When you do that, that's minus -1/4. Yep, that's what I had earlier, right? And now try the opposite side is AB. Let's find the slope of that. And the two values that I have over here, right minus left, -2 minus -3. And then the right minus left of the x value is x values are -1 minus 3. And that will give me 1 over -4. So they're equal to each other, right? So now because the slope CD is equal to the slope of AB, I would say that CD is parallel to AB. Okay. Now we do the same for BC. Okay, so do me a favor, guys. Fill out the space over here to show these two and write down the conclusion. Okay, when you do that, that's what you end up with. So BC is equal to, slope is 1. Yep, it is 1. That's 1, 2, 1, 2. 2 over 2, that is correct. So they're equal to each other, so they're parallel. Quadrilateral ABCD is a parallelogram because both pair of opposite sides are parallel. What else could we do to prove quadrilateral ABCD is a parallelogram? I think there are a total of 4 aside from the definition. Do we not? Yeah. The first is what? Opposite angles are congruent. Well, we can't really use that because we're learning how to do what? Because we don't know how to find angles actually, right? And then we know that the opposite sides are parallel. That's defined. That's the definition. But that's what we just did. So we could use the slopes, right? And opposite angles are congruent. And what else do we have besides that? I think what we have is a opposite pair is both parallel L and congruent, right? Okay. What else do we have? That's right. We got opposite sides are congruent. So here we could use the distance formula, right? For geometric proof. So that's definitely possible. And this one we could use slope and distance formula for single pair of sides, right? So I think that's possible. But for this particular section, no. For this particular section, this one is good. The definition of parallelogram, right? The other is what? Diagonals bisect each other. Okay. The way to show that is that if you could show that this is the midpoint of this segment and that is the midpoint of that segment right there, then I think that's how you could do that as well, right? So this one you would need midpoint formula, right? So these are the things that we could do, these three, for what they call coordinate geometry. And what we're doing right now is part of coordinate geometry, right? We're using coordinate values, using slopes to show certain attributes of the quadrilaterals to be true, right? And then the wider array of coordinate geometry includes using distance formula and the midpoint formula, along with our stuff that we're doing right now, okay? All right, guys, let's wrap up the part 1. So we got your turn over here. You got question number 4 and 5 and 7 and 8. Please pause the video. All right, guys. I didn't have that cool picture. I didn't have a chance to copy import it here, but here is the answers and solutions for 4 and 5. Okay, guys. Let's slide up now and 7 and 8. We good? All right, guys. I'll just continue on with part 2 because they go hand in hand. So right now we're going to be doing what? Perpendicular. And I mentioned earlier, which way do we, using slopes, how would you know that the two lines are perpendicular? If you said the product of the slope is equal to -1, then you're correct. I want to stay away from saying that the slopes are negative reciprocal of each other. It is more succinct to say that the product is equal to -1. Okay, here you go. If you have two non-vertical lines are perpendicular, right? If their product is -1, that's what I've been saying, right? So this is very similar to what we did earlier. Okay, show that QRST is a rectangle. So how are you supposed to do that? I believe, if I'm not mistaken, there are a couple of ways to do this, right? Number one, you could show that it's a parallelogram with a one right angle, right? Or you could show that it has four right angles. Yeah, that's one of the two ways, right? Yeah, just why don't you give it a try and see what we could do with that. And then let me give you a hint over here as well. And in this one, it's the same thing. We have an equation over here, right? We're going to assume that they're going to intersect each other. See if they do. I could draw some random pictures over here. Well, it shouldn't be random, but it doesn't have to be exact, but just give it a go. All right, guys? All right. Pause the video, guys. Here we go. As I said before, there are two ways. The first, QRST is a rectangle if you could show that it's parallelogram and has one right angle, or QRST is a rectangle, right, if all four vertices are right angles. Either way you do it, you gotta find slope of all four sides, and I did. Okay, so I didn't bother writing out all the steps, right? But the QR is 1/2, ST is 1/2, so they're parallel. Do you see that? They're parallel because the slopes are equal to each other. And then QT, this QT, the QT slope is -2, and RS slope right there is -2. So they're equal to each other. In this case, I just count them, okay? And then they're parallel to each other because the slopes are equal to each other. And that right there, I arrowed it out and said QRST is a parallelogram. And then we just need to choose one. I'm going to go with the right angle R because the product of the QR, which is 1/2 times RS, -1/2 is equal to -1. QR and RS is perpendicular, which means they're right angle, right? Therefore, I basically used the first one. I think that's probably easier and quicker. Because we have to find it anyways, right? We have to find the slopes anyways. It's quicker to say that these two opposite sides are parallel than to do four products, right? Anyways, therefore QRST is a rectangle. All right, guys, let's go to the next example. What I did was I kind of worked it out and drew the picture. This is L, this is J, C, and a B. L, C, small letters, J, and a B. Okay. So what did I do? This one, y is equal to 2x plus 8. So y-intercept is 8. My slope is around 2, and there you go. This one was a little hard to do. So there are two ways to graph. Either y is equal to mx plus b, the slope-intercept form that you've been doing it for a long time, or if you write it this way, we could do what? XY-intercept. Okay. Anyways, so this is the rough picture that I did, and I solved for y for all four of them. I wrote it over here, guys. And these two have slopes of 2, so they're parallel. So J and B, L and C, right, are parallel. And then roads Johnson and Brennan Road have slope of -1/2 going down this way. And they're parallel. So, and I decided to label this PQRS, so I want to call it something. This is a parallelogram, and Q right here is 90 degrees. You could have chosen any one of them, and that's the intersection of the L and J, isn't it? So I say M sub L times M sub J is equal to -1, so they're perpendicular. Because it's a parallelogram with a right angle, PQRS is a rectangle. Okay, guys? All right. Okay. So we have one more, right? For this one, I'm going to write out nice and slow, if that's okay with you guys. Okay. So this is a multi-step. Determine whether the quadrilateral with the given vertices is a parallelogram. If so, determine if it's rhombus, rectangle, or neither. Justify your conclusion. Oy, 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 oy. So I think the easy way to do this, there's many properties of each, right? But I think the thing is that is different about rhombus is the shape. All four sides are equal, but more importantly, the diagonals are perpendicular. For rectangle, right, I'm going to exaggerate the rectangular shape right there. When I cross line this way, clearly these two lengths are the same, but we're not doing the distance formula, so we don't care. But clearly these are not perpendicular, right? So that's what we're going to do. Okay, guys. All right. So A, what is A? It's -3. 1, 2, 3. That's A. B is 1, 2. 1, 1, 2. That's a B. C is 2, 0, which is here. And that's -2, -2, which is about here, D. So it looks something like this. I mean, it looks like a rectangle to me, personally, right? But the important part about this is that it's quadrilateral ABCD, meaning it goes A, B, C, D. It goes, wraps around this way, right? Okay, guys. Now what we're going to do is, what I want you to do is find the slope of AB. And we realize that, and slope of DC, that they probably look about the same, right? And then I want you to find the slope of BC. What's opposite of that is AD, right? And slope of AD. And I'm going to guess that because they're equal to each other, we could say that the AB is parallel to DC. And this over here, guys, I'm going to assume that BC is parallel to AD. So your job is to show that this and this value is the same, and this value is the same, using rise over run. Okay, y2 minus y1 over x2 minus x1. Okay, guys? All right. And then we're going to show one of them is a right angle, right? But that's not enough here. Well, I guess it is. So I want you to give it a shot. Go right ahead. Okay. What you should have had was, this is half and half, therefore they're parallel. -2 and -2, so they're parallel. Since both pair of opposite sides are parallel, ABCD is parallelogram. Now I know that B over here is a right angle because the product of segment AB and BC, what's AB equal to? 1/2. BC is equal to -2. It's -1. So I know they're a rectangle, right? Because of that, we could say that ABCD is a rectangle. The question is, could we say that it is a square? Okay. A special kind of rectangle is a square, and if something is parallelogram and a square, then it is a rhombus. I'm sorry, I meant to say, if something is a square, right? If something is a rectangle and a rhombus, then it is a square, right? Now, looking at the picture, clearly these two lengths are different. It's probably not a rhombus, but this question suggests that we find whether the diagonals are perpendicular, right? So we should go ahead and find the slopes of these two. As it turns out, the AC is a 0, clearly, and BD is, when you go through the calculation, is 4/3. Because it is not equal to -1, we could say that they're not perpendicular, therefore it is not rhombus, right? So this tells us not rhombus, right? Because one of the properties, one of the properties of a rhombus is that diagonals are perpendicular, right? All right, guys, that is it. Okay. We do have your turn We've got 5 and 7. Why don't you pause the video and do the best you can. Okay guys, we're back. If you could get this right without much prompting, then you're in great shape. If you had to refer back to the notes, then means we have a little more work to do, right? Here we go. So if you have any questions on these, I will talk about it in class, but here is the solution. And 7, here it is. All right, guys, that's it for me. I'll see you in the next video. Have a good night.